Hey there, folks. Okay, so what you saw in that demo video was that the hot water made the dye molecules in the red food coloring spread out really fast, and the cold water prevented the dye molecules from spreading so fast. Those dye molecules stayed mostly clumped together. They spread a little bit, but in hot water, they spread much faster. So again, back to what Robert Brown saw back in the 1800s. He saw those pollen grains wiggling and moving. So if you look at this lower animation, this is not really to scale. Water molecules are much, 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 much smaller than a pollen grain, maybe about 1,000 or 10,000 times smaller. But those water molecules are bumping into those pollen grains from every direction. The water molecules are moving randomly, and if enough of them happen to bump into the particle of pollen on one side, it moves it a little bit in one direction, but then it gets bumped from the other side and it moves back in the other direction. So the pollen grain's random motion, that random wiggling motion, is due to the random motion of those many, 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 many small, 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 small water molecules. Okay? So again, in the hot water, the particles were moving differently than in the cold water. The water molecules in the hot water must be moving very fast. They have a lot of kinetic energy. The water molecules of the cold water are moving slow. They have much less kinetic energy. So there is a connection between kinetic energy and temperature. Hot water, higher temperature, relates to more kinetic energy or higher average kinetic energy. Cold temperature relates to a lower average kinetic energy of the particles. Okay, so you could think of it this way. The particles in a cold substance have lower average kinetic energy. The particles in a warm or hot substance have more average kinetic energy. The average kinetic energy of these particles over here in the hot water is higher. The average kinetic energy of these particles in the cold water is lower. In both cases, you can have some particles that are moving fast and some that are moving slow, but the average kinetic energy is greater in the hot water. Average kinetic energy is lower in the cold water. Okay. And we also will eventually talk about IMFs. The intermolecular forces in this hot water must also be weaker because the particles can move around more. So that kinetic energy is overpowering the IMFs, or the IMFs are weaker in that hot water. Okay. And that's where I'm going to stop. Thanks for watching.